So these are our first set of examples where we have the square on the top, different squares, and just the x minus 5 on the bottom. And these are the simplest of the three examples we're going to do. So you can just simplify that so you get x minus 5 times x plus 5 all over x minus 5. And then what you can do with that, cancel those. So you're left with x plus 5, and then the limit as x goes to 5, the x plus 5 is 10. For a similar problem, we get the limit x goes to negative 3 of x squared minus 9 over x plus 3. Do a little simplification, x plus 3, x minus 3. That is the factoring of that difference of two squares. All over x plus 3. Get your cancellation in, and you're left with x minus 3. And so the limit as x goes to negative 3 of x minus 3 is negative 6. Now looking at the more general case, the limit as x goes to a of x squared minus a squared over x minus a. We can do the same thing. That's still a difference of two squares. We can still do this factoring. So x plus a times x minus a all over x minus a. Not very good at a. Let's try and fix that there. And that's equal to x plus a. So the limit as x goes to a of x plus a is obviously 2a. So that's our pattern. Let's move on to a square root problem now, and multiply the conjugate as well. So this is the limit as x goes to 4 of root x minus 2 over x minus 4. So we want to multiply the conjugate. In this case, it's root x plus 2 over root x plus 2. That makes sure that we have 1 over 1 that we're multiplying by, so we don't screw up the equation. So that leaves us with x minus 4, which is, the square root of x squared. And on the bottom, we have the x minus 4 left over, and the root x plus 2 that we multiplied in. Well, this x minus 4 is going to cancel, so we're going to get left with 1 over root x plus 2. The limit of that, limit of as x goes to 4 of 1 over root x plus 2 is going to leave us with 1/4. Moving up in difficulty a bit here, we got the limit as x goes to 10 of the square root of x minus 1 minus 3 all over x minus 10. So we're going to multiply by the conjugate. The conjugate in this case is going to be x minus 1 plus 3, x minus 1 square root obviously. And then in the bottom will be the same thing. And what that'll come out to be when you multiply that all together is x minus 1 minus 9 on the top. And on the bottom, your x minus 10 from the beginning, and your conjugate, which is x minus 1 plus 3. Now these are going to cancel if you simplify that top, and what you're going to be left with is 1 over the root of x minus 1 plus 3. So then if you take the limit of that, as x is still going to 10, of 1 over x minus 1 plus 3, you're going to be left with 1 over 6. Now if we look at our general case, the limit as x approaches a of root x minus root a over x minus a. The root a is just like, imagine a is 9, then root a would be 3 and all that. But anyway, what you want to do there is not equal. You still want to multiply with the conjugate, which is root x plus root a, and then over itself. So what that's going to get you is x minus a when you do the difference of two squares on the top, another x minus a on the bottom, and then your root x plus your root a. As usual, those will cancel. You're left with 1 over root x plus root a. Limit as x goes to a, sorry, not the root a, just an actual a. I'm not changing the limit here. And root x plus root a what you're just going to be left with is 1 over 2 root a. And that's your pattern for these kinds.
Hey everybody, Mr. Howard jumping in here to add to Isaac's video, thinking about what he just said about this pattern for these square root problems. If we have a limit as x approaches 9, we would have square root x minus square root 9 over x minus 9, which of course simplifies to square root x minus 3 over x minus 9. And then by Isaac's pattern that he just laid out, we should get an answer of 1 over 2 root 9, which equals 1 over 2 times 3, which equals 1 over 6. Okay, so this follows the pattern. Now I want to talk about one other case really quick. So looking down here, notice the difference here. We have square root x plus 13 instead of just square root x. So now when we do this algebraically, we're going to end up getting 1 divided by square root x plus 13 plus 4 when we do our conjugate work. Okay? And then we're going to be able to plug in 3 for x. And our final answer ends up being 1 over square root 16, which is 4, plus 4, which equals 1/8. So it's important to recognize in problems like this, we basically end up with 1 over this number doubled, right? We get 4 plus 4 here, because we get the plus 4 from the conjugate. This switches to a plus 4. And then when we plug in our limit, as x approaches 3, well, this is also going to be 4. So these two numbers always end up being the same. And that's just important to recognize when it's not just square root x, but it's square root x plus or minus something under the square root sign.
Now moving into our third kind of problem, the common denominator problem, we got the limit as x goes to 2 of 1 over x minus 1 over 2 all over x minus 2. So you need to get the common denominator by multiplying that first part by 2 over 2, second part by x over x. So what you're going to be left with is 2 over 2x. Yeah, just imagine that's an x minus x over 2x. That's equal to 2 minus 2x over 2x. Pull the negative out in front, you get negative x minus 2 over 2x. And then if you shove that all back together, you're going to get negative x minus 2 over 2x x minus 2. And those will cancel, and the limit as x goes to 2 of negative 1 over 2x is negative 1/4.
Okay, Mr. Howard jumping back in here to finish up this video. So with problems like this, we always end up with this step of finding the common denominator. So we want to find a common denominator for these two fractions. So we get, well, we need to put a 2 here because this one has a 2, so we get 2 over 2 times x minus 1. And then this one needs an x minus 1, right? So we give it x minus 1 over x minus 1. And now we can combine these fractions because they have the same denominator. And the thing is, we have to distribute this negative to both pieces. So how this will simplify is 2 minus x plus 1 over our common denominator over x minus 3. So then that simplifies. We have 2 plus 1 is 3. So we have 3 minus x over 2 times x minus 1 over x minus 3. Okay, x minus 1. And then when we factor out our negative to make it so we have the matching factor on top and bottom, that gives us negative x minus 3 over 2 times x minus 1 over x minus 3. When you have that sandwich, we're going to cancel the bread. So now we have negative 1 left on top. On bottom we have 2 times x minus 1. And now that we've canceled our factor causing the hole in this limit, we can now just plug 3 directly in and see what we get. And what we need to notice here is we get negative 1 over 2 times 2, right? Which this again ends up being negative 1/4, just like in that last example. So in general, what we're seeing here is with this common denominator, we're always going to get this number multiplied by itself when we plug in our limit. So if you're looking at a limit like this, you know it's going to be negative 1 divided by this number squared if you have a hole in your limit in this type of problem. So last one, just to solidify this pattern, we see if we plug in 7, we get 1/12 minus 1/12 over 7 minus 7. So we do have a hole at this limit. And by our pattern, we should end up with an answer of negative 1 over 12 times 12. Negative 1 over 12 squared, which is going to be negative 1 over 144. Okay. These types of problems will always follow this pattern.